Today we're going to talk about partitioning line segments. First thing we've got to discuss is partitioning line segments is ratios. We're very familiar with proportions. Proportions, if I give you the proportion 3 out of 9, this is very common. We're used to comparing a part to a whole. So if we have a 3/9 proportion, that means 3 out of the 9 is going to work. Now, a ratio is different. A ratio is comparing one part to another. So the key word in partition is part. So we're basically looking at what parts of the line. So in my scenario here, this is a 3/9 proportion. This would be a 3/6 ratio, because there are 3 parts that will succeed and there will be 6 parts that will fail. So this is what a ratio is. It's comparison from one part to another. And like we said, part is our key word today. What part? Partition of a line segment. We've dealt with midpoint, which is where we cut a line right down the middle. We've got a line and we're trying to find the middle of those 2 points. Now we're going to look at a different spot. We may find a line that's 1/8 of the way. And that's what we'll work on today. Let's take a look at a few examples. So what we're looking at here is a coordinate of -4, 2, and a coordinate at 5, -4. And it even tells us what are the coordinates of the point directed line segment from 4.2 to 2.4, -4, 2 to 5, -4. So that would be this segment right here. And then it also tells us this, since it told us the direction is from -4, 2 to 5, 1, and the partition is a 5 to 1 partition, that means the 5 segment is going to be the longest segment first, going in our direction. Well, I'm not exactly sure where it's going to be, but I know it's going to be somewhere along that line. And it's going to be closer to our second point because it's a 5 to 1 ratio. Now again, we are not comparing. In this case, this is a ratio. So we need to find where the proportion of this line is going to be. And what we actually have is 5 parts and 1 part for a total of 6 parts. So this is a 6-part ratio. So what we need to do is find the distance between each of these values. We're going to find the distance between the x values, and then we will find the distance between the y values, and then we will calculate our partition. So on our x values, we went from 5 to -4. So what we do is we always just subtract these numbers. So our formula on this, and we'll give this to you a little later, is x1 plus the ratio from 1 plus the ratio from the second. And then we are going to multiply that times x2 minus x1. And it doesn't matter which one this is actually, because the distance is what it is, because you can see that I've actually done I did do x2 minus x1. So what I learned is these parts are 9 points away. They're 9 points away. I actually don't usually use this formula. What I do is I just create my proportion. So this is my R1 in case you do want to use this formula, and this is my R2. But what I need to know is that we are going to be 5/6 of this distance away. And since the distance is 9, we are going to be 5/6 of the way. Now we started at point -4. So we're going to add this value to -4. And what this will do is this will give us the x value. So if we go 5/6 of 9, this is a decimal answer, we will be at 7.5. So that's the distance we're going to need to travel along the x-axis. And since we started at -4, we will add these two numbers together, and when we travel that 5-to-1 ratio, we will have moved from -4, which is over this way, because remember, this is a distance of 9. It's a distance of 9 to travel this far along the x values. I'll do that in a different color, actually. We traveled a distance of 9 to go this far. So our partition line is a 5-to-1 ratio. That's dividing it into 6 parts. So when we divide this into 6 parts, we will have gone 7.5 compared to 1.5 on the x-axis. Now, so you can tell my 7.5 is off. It should be at 3.5 actually. But this is what we are computing when we use our formula there. And we're going to do the same thing with y. Well, the y has traveled from 2 all the way down to -4. Well, that's a distance of -6. Or excuse me, not negative. Remember, that's distance. So it's traveled a distance of 6. And we're going to need to go 5/6 of that way. But let's just use our formula. So our y value, what we're going to be doing, since we're now dealing with the y's, we will start at 2. That's because of this. And then we will calculate our ratio. Now it's going to be the same thing. I would not go back to this formula. It's going to be the same amount, which is 5/6, because that is our proportion. And now we will do our y values just the same we did our x. So I'm starting at x1, so it's very important you get this part right. So I started at 2, so my x2 value would be -4 minus my y1 value, excuse me, -2, +2, excuse me, and it ends up being negative. So still starting at 2, we're going to travel 5/6 of the way down this line. We said it's a total distance of -6. 5/6 times -6 is going to be -5. So the distance traveled will be down 5. Since we were at 2, we will go down 5 from there, which would put us at -3. So our answer is the ordered pair 3.5, -3. Just like midpoint, we found the distance halfway between these 2 points. It's the same thing here. We found that -3 was our partition point here, and +3.5 was our partition point here. And when we drop this line down and we move this line over, that's where it puts us at our solution, 3.5, -3. We're going to take a look at a few more examples. Here's another one with just 2 points. So we can see we have a point at -4, 3. And we have a point at 5, -6. And our partition line is a 4-to-5 ratio. Well, that means we have a total of 9 parts. 4 parts will be on this side, so we're going to be closer to the second point, the first point this time, excuse me, because we'll only go 4 steps. So we'll do our distance with the x here. Let's try to color coordinate this one. We'll do the distance with x in red. We'll do the distance in y in green. So just like our formula said, we can calculate that, but really, let's just think about what we are doing. It's a 4-to-5 ratio. So the 2 parts are 4 and 5, which is a total of 9. So we are going to be going 4/9 of the distance on either of these two, actually. If we wanted to start constructing the y at the same time, we could. I don't think I will, but we'll take a look at it. So we're going to go 4/9 of the distance. Well, the distance in x, there's our x1 value, y1 value, x2 value, y2 value. We will need to do our x2 value minus our x1 value. Well, we're ending up with a negative minus a negative 4. So that's going to end up looking like that. And we are going to, whatever this proportion is, we're going to have to add to the negative 4 because that's where we are starting. That's where we're starting there. So let's just calculate this thing. To move from negative 4 to positive 5, if we did this in a horizontal line, whoops, we'll just do horizontal at first. What we have is a distance of 9. Now, this is really nice because our denominator is 9. So we can divide these parts out evenly. If you think about it, think this through. This is 9 parts. And we are 9 points away, which means each unit is its own part. So when we move over 1, 2, 3, 4, that's where our part would be. But let's just go through the equation here. And we can keep counting that, by the way. 1, 2, 3, 4, 5 parts. Because we're dividing it into 9 parts. 9 units, 9 parts. Each part is 1 unit. So we just carry down our negative 4. We have a 4 divided by 9 and then immediately times 9. Anytime you multiply and divide by the same number, they're going to cancel one another. And we end up with negative 4 plus 4, which is 0, which we just learned as we walk through this. So our x value for our partition is at 0. Y value, we're going to do the same thing. Let's go ahead and count this distance down, though. We go from positive 3 down to negative 6, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 whole units. We're going to create the equation, but just keep in mind that's 10 units. Here's our formula, though. We will take y2 correction. Apparently I cannot count. Counting can be difficult. This is down 1, 2, 3, 4, 5, 6, 7, 8, 9 units as well. Again, this is just a coincidence. But we go from negative 6. It's a coincidence that those are the same. They don't have to be the same. But since they are the same, we can start addressing some things, kind of like this is a isosceles right triangle, because both of the sides are the same. And this is going to go 4/9 of our distance. And let's not forget that we start at the point y value 3. So again, if we think this through, 9 units, 9 parts, each hash mark, each tick mark is its own unit. So this one, though, we do have negative signs, so it's very important we keep this in mind. The 9s cancel, but the negative sign does not. So that ends up being negative 1. So we end up with 3 plus a negative 4, which is, of course, negative 1. Now let's count our parts as we go down here. 1, 2, 3, 4 parts does put us at negative 1. So as we move over, this is going to go down, and this is going to go over. So you see I'm not on the line, so I've clearly made a mistake, and I see where it is. I didn't go from the point 0 like I was supposed to. I went from the point 1. So let's try that again. Down 1, 2, 3, 4. And then these two do meet where they're supposed to. If you notice, it doesn't technically touch the line, but that has more to do with my poorly drawn line than it does anything else. All right, this one's a little tougher, can be a little tougher. What we have here is points N, O, P, and Q. These are all on our line segment here. So I'm going to go ahead and label these. In. And I'm going to try to follow my ratios here, which this one tells me it's 5 parts. So this is pretty long to get to O. Then it's a 2-parter to get to P. And then our last one is Q. I'm not going to worry too much about these lines, but technically the P would be, we'll just move it over a little bit. The P is going to be a little closer. And since this is 5 parts, this one is 2. The O is a little too big as well. So twice as much as the P, but less than half of what the NP is. So here's what we need to do first of all, is we need to recognize that NQ is 24 units long. NQ is 24 units long. And then the second thing we need to notice is how many parts do we have? So it's a 5-part from here to here. That's 5x, because it's 5 parts, to 2 parts, to a 1 part, which this is x. Well, if we have a 5, 2, and 1, that's a total of 8 parts. 8 parts. Well, we're dividing a line in Q, which has a distance of 24, and we're dividing it into 8 parts. Okay, well, 24 divided into 8 parts means that each of those parts is 3 units long. So each of these parts is worth 3. If you think about this kind of like the stock market, your shares, this company, everybody has the same share. If I own, property, shares in Walmart, the price for me is the same price as somebody that owns millions of shares. But the amount of shares we own is very different. This right here is the equivalent to the price of the share. Okay, the price of this share is 3 units. Well, our point from N to P owns 5 of those shares. So if it owns 5 of those shares, that's a total of 15, because the share is worth 3 and it owns 5, which means it has 15. Same thing here. We've got a partner that doesn't own as many shares, but the share is still worth $3, or in this case, 3 units. This is not dollar amounts, but hopefully you get the reference. So this would be 6 units. And then this one right here only owns 1 share. So this would be 3 shares. So once we've divided these up, these should add up back to our 24, which 15 plus 6 is 21, plus our 3 does add back to 24. So this accounts for our 24 units. Now we've got to make sure we answer the question that's being asked, which the question that's being asked is, what is the distance from NO? And as you can see, I guess when I marked my things off, I changed my P to an O, making a lot of mistakes today. That's okay, as long as we fix them. So from N to O is our big shareholder, which was 15. So our segment NO is going to be equal to 15. All right, I've managed to make a mistake on every single one I've done today. I want to break that record here. Let's see if I can do that. Mistake free on this one. We'll see. Here's hoping, right? If not, it's okay. So we have a line LO, L to O, which has a length of 33. Let's go ahead and get that down there. So you notice our ratios, 2 of them are the same. And then this one is a smaller ratio here. So it tells us line segment LM and O. So we're going in alphabetical order. My smallest segment is LM. And then the other two are equal. Tried to put that in the middle. That wasn't very good. Let's try that again. Still not great, but you guys get the idea. So this would be point N. Let's just double check. I want to try to really not make a mistake here. LMNO, so we got them all. So what we need to do now is establish how many parts do we have? Well, 3 parts here, 4 parts there makes a total of 7. And then an additional 4 parts mean that we have 11 shares, or 11 parts, excuse me. So we're dividing our LO line of 33 is being divided into 11 parts, which, just like the last question, this equals segments of 3. So what we need to look at as well is see, okay, how much of each of these partitions do each of these owe. So well, LM had a ratio of 3. MN had a ratio of 4, so they get 4 of the shares. And then NO also had 4 shares because those are equal. Those are equal distance. So there we have it. And we have equal shares of each of these. So 3 shares at $3 is a total of 9. 3 parts, excuse me. The second one, we have 4 parts, and they're each 3. So that's a total of 12. And if that one's 12, then this one, of course, is going to be 12 because we know those are equal. So we have a total of 12 and 12, 24. 24 plus 9 is, in fact, 33. So this does check out that I've divided it into correct proportions, or partitions, excuse me. So the only thing I need to do now is identify the line that they're talking about. Now, pay attention to this as well. They were kind to us and put 2 lines that were side by side. But remember, they could have asked us for the line segment LN. If that's the case, all we're going to do is our add segment addition postulate and add those together. But in this case, all they asked us for was the length from M to N, which, as we can see, has a length of 12. So what we have here is MN equals 12. Hopefully that's right. If that's right, I did get a question completely right today, so that would be nice. All right, let's get to work on those. Good luck.